Chapter 15, Part 2, we will talk about conditional probabilities. So the probability that one event occurs under the condition that another event is known to have occurred is what we call conditional probability. So suppose we know that event A has happened. It's guaranteed that this event has happened. Then the probability that event B happens, given event A has happened, is denoted by the probability that B occurs given, we use this little bar here, event A. Okay, so there's two options here for events A and B. We could find the probability of A given that B happened. That would be denoted as the probability of A given B. Or we could say the probability of B given A, which in this case would switch your A and B. I do want to point out that the second part here is the condition. This thing needs to be met first. So even though it's written second, this is the condition that you have to meet first. Okay, so our first example says use the two-way frequency table below to determine the probabilities. We want to look here, and we're going to write the probability and then write in words what that means. So it looks like we have males and females here, and then we ask them whether they enjoy reading or do not enjoy reading. So the first one says that I want to find the probability of a female given that they enjoy reading. Now this enjoy reading is the given. This is the condition. I need to start with finding how many people enjoy reading. So if I'm looking at my table, enjoy reading is this column here. That means there's 31 people that enjoy reading. That 31 is going to be my denominator. Out of those 31 people who enjoy reading, how many of them are female? Well, looking just at my 31, looks like there are 12 that are female. 12 out of 31 gives me 0.3871. Okay, now what this means in words is that 38.71% of the condition, so of people who enjoy reading, are female. 38.71% of that condition, enjoy reading, are female. Now, if I flip the order here, so now I'm looking at the probability that somebody enjoys reading given they're female, this does change things quite a bit. Now my condition is that they must be female. So when I look at my table here, okay, the first thing that I'm going to do is look for females. So females, it looks like, was a total of 40. Out of those 40 females, how many enjoyed reading? It was 12. So 12 out of 40 gives me 0.3. This now means that 30% of females enjoy reading. So order is very important here. I like to think about this in context. So pretend we had 100 people at the school. In this first one, what I would do is start with putting everybody who enjoys reading into a room. That would be the 31 people. And then I would look at just those 31 and ask how many of them are female. This one, I would start with taking all of my females and putting them into the room. There'd be 40 females. And then I would ask all those females who enjoys reading. Very, very different here. Your condition is what tells you what happens in the denominator. Go ahead and pause your video to try part C. Okay, for part C, the condition was that they don't enjoy reading. So I look at does not enjoy reading. That gives me a denominator of 69. And then out of those 69 people, how many of them are male? That gives me 41. So I would say 59.42% of people who don't enjoy reading are male. Okay, on page 24, we can also answer conditional probabilities when given a Venn diagram instead of a table. So let's go through a few here. It looks like in our Venn diagram, we have people who like comedies versus those that like thrillers. 5% like both, and weirdly 50% do not like either one. So I'm looking for the probability that they like A given they like B. So B is my condition. This is what needs to happen first. So I'm going to look at B, which is thrillers, and I'm looking everything in this circle here. So 5% and 15% gives me a total of 20%. That's going to be my denominator. I'm going to write that as 0.20. You could just write it as 20. You're going to get the same answer either way. Okay, now only looking at these 20% of people, because I need to just focus on those that like thrillers, what percent of people like A as well? Well, that overlap is 5%, so 0.05. Okay, kind of tricky. You want to make sure that once this denominator is identified, so once you know just that 20% is what you're focusing on, continue to only focus on that 20% when you look for your numerator. So I'm going to type in 0.05 divided by 0.2, we get 0.25. Okay, this means that 25% of people who like B, so thrillers, that was the condition, also like A, which is comedies. So 25% of people who like thrillers also like comedies. Okay, part B, probability of B given A is now flipped the condition. So now the condition is that they must like A, they must like comedies. So looking at my Venn diagram here, I want to focus on everything in A. That is 35. Again, just looking at that 35%. How many people also like B? So part of B would just be that 5%. Give me 0.1429. So 14.29% of people who like condition. The condition was comedies. Also like B, which is thrillers. So very similar to what we saw on the last page. The only difference is now that the information is given to us in that Venn diagram. We are going to skip part C on this page. It's almost the exact same problem as part B, so it seems kind of silly to do it. Let's go ahead and look at the next page. Okay, question 3 is asking us to find some conditional probabilities looking at cards. So part A says find the probability that it's a red card given it's a jack. So the condition is that it's a jack. So I'm going to start with looking at my cards and counting how many jacks there are. It looks like there are 4 jacks. So just looking at those 4 jacks, only focusing on your jacks. How many of them are red? Well, it looks like only 2, which is 50%. A lot of times if you're going too fast, you'll write down 4 for the jacks, and then you'll look at all red cards, which you'd put 26 here. That's going to give you a probability greater than 1, which we know we can't have probabilities larger than 1. Okay, next one, I want to find the probability of a 9, given that the card is black. So the condition is that it's black. So I'm going to look at all my cards. These are all of the black cards. There are 26 of them. Looking just at those 26 cards, I want to find how many of them are 9s. There are 2 9s here that are black. And that gives me 0.0769. Go ahead and pause your video. You guys can try C and D. Once you're done, go ahead and press play, and I can show you my answers. Here are the answers for C and D. For C, you were looking for diamond given red, so we should have started with looking at the 26 red cards. There are 13 of them that are diamonds, so 0.5. And then the last one, I'm looking for queen given that they're a face card. Face cards are cards that literally have faces on them, so that's your jack, queen, and king. There are 12 face cards, so that was my denominator. And then I want to look at the number of queens. So there's 4 queens, giving me 0.333. All right, last one here. Number 4 says the data in the table below were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. So X is going to bed early, Y going to bed late. These people couldn't tell us any dreams. These guys had 1 to 4 dreams, and these guys had 5 or more. Okay, part A says, find the probability that somebody had 1 to 4 dreams given that they were in Group Y. Group Y is my condition. This needs to happen first. So looking at Group Y, there's 100 people. Out of those 100 people from Group Y, I'm going to look for people that had 1 to 4 dreams. So that would be 11. 11, the denominator is 100. Nice and easy. Okay, part B says find the probability that someone was in Group X, given they did not have any dreams. So my condition now is that they had no dreams. That's this column. That denominator should be 36. Out of these 36 people, I want to find how many were in Group X, which is 15. A, C, and D are a little bit tricky. Part C says find the probability that somebody's in Group Y, given they had at least 1 dream. So at least 1 dream is actually a few categories here. People in 1 to 4 had at least 1 dream, but people who had 5 or more had also at least 1. So my condition is actually looking at all of these people here. So to find that denominator, I would have to take 39 and add it to 125. Now you can show your work there, or you can just add it first and put 164 as the denominator. But there were 164 people in total that had at least 1 dream, so they had 1 or more. So looking at these 164 people in these 2 columns, I now want to find how many were in Group Y. So Group Y were these 2. So I'm going to take 11 and add it to 68. So that should give me 79. I can type in 79 out of 164, and I get 0.4817. So roughly 48% of people who had at least 1 dream were from Group Y. And part D here, switching up the order. Now I'm looking for the probability that they had at least 1 dream, given they were in Group Y. So my condition has now changed. This time I'm going to start with identifying people that are in Group Y. So Group Y was this right here. That's a total of 100. But I want to find people that had at least 1 dream. So that would be not the 21, but the 11 and the 68. So again, I have 79. So this means that 79% of people from Group Y had at least 1 dream.